Have you ever wondered how your phone dims its screen? Or how a drone motor speeds up and slows down so smoothly? Or how a tiny microcontroller can control a motor that draws way more power than it can ever output directly? The answer to all of these is PWM. And once you understand it, you're going to see it absolutely everywhere. PWM stands for Pulse Width Modulation. That's a fancy name for a very simple idea. Instead of sending a smooth in-between voltage, say 2.5 volts from a 5 volt pin, a microcontroller rapidly switches a pin on and off. And by controlling how long it stays on versus off, it tricks things into behaving as if they got a lower average voltage. Think of it like this. Imagine you are flipping a light switch on and off really fast, 1000 times per second. If you keep it on half the time and off half the time, the light appears about half as bright. Keep it on 80% of the time, pretty bright. Keep it at 20%, quite dim. Your eyes average it out, and so does your motor, and so does your speaker. That on time as a percentage of the total cycle is called the duty cycle. 50% duty cycle means the signal is high for half the time. That's the core concept right there. Now here's a question smart people ask. How fast is the switching actually happening? That's the PWM frequency, and it matters a lot depending on what you're driving. For an LED or a servo monitor, a few hundred to a few thousand hertz is plenty. For audio applications like generating a tone, you need much higher frequencies. And for power electronics like motor drivers or DC-DC converters, you might be switching at tens or even hundreds of kilohertz. Why does it matter? Because if you switch too slowly, you'll actually see the LED flicker or hear an annoying buzz from your motor. The higher the frequency, the smoother the result, up to a point. In a microcontroller like an Arduino, PWM is handled by a hardware peripheral called a timer. You don't manually toggle the pin in your code. That would be too slow and inconsistent. Instead, the timer does it automatically in the background, perfectly timed, while your code does other things. On an Arduino Uno, pins 3, 5, 6, 9, 10, and 11 support PWM. You just write one line of code. The value goes from 0 to 255. 0 means always off, 0% duty cycle. 255 means always on, 100%. And 128 in the middle, about 50%. Simple. Under the hood, the timer is comparing that value against a counter that counts up and resets. When the counter is below your value, the pin goes high. When it's above, it goes low. That's it. That's the hardware doing the work for you. So where do you actually use this? Everywhere. Motor speed control. You can't safely send a variable voltage directly from a microcontroller to a motor. The controller can supply that current. Instead, you use PWM to drive a transistor or a MOSFET that switches the full motor supply on and off. Change the duty cycle, change the speed. Servo motors. These are a special case. Servos don't respond to duty cycle for speed, they respond to pulse width for position. A 1 millisecond pulse usually means 0 degrees, and a 2 millisecond pulse means 180 degrees. The servo reads the timing and moves to the right angle. This is used everywhere, from RC cars to robotic arms. LED dimming and RGB color mixing. You've been using this every day on your phone. By mixing PWM on red, green, and blue LEDs at different duty cycles, you can get any color you want. Audio generation. If you output PWM at audio frequencies and filter it with a simple low-pass circuit, you can generate sounds, tones, even crude speech from a basic microcontroller. Here's something that trips up beginners. PWM is not a true analog signal. It's a series of digital pulses. If you're driving an LED or a motor, that's fine. They naturally average the signal out. But if you want a true analog voltage, say for an audio output or a sensor input, you need to filter the PWM signal with a low-pass RC filter. That smooths out the pulses into a steady voltage proportional to your duty cycle. No filter, you'll get noise, buzzing, or weird behavior. PWM is one of those ideas that seems simple on the surface but powers an enormous amount of real-world electronics. Once you understand it, you'll recognize it in motor controllers, power supplies, audio circuits, LED drivers, almost everywhere signals meets the real world. If you want to go deeper, try experimenting with analog write on an Arduino, hook up an oscilloscope or even a logic analyzer and watch those pulses in real time. It's one of those moments where the concept just clicks. If you found this useful, hit subscribe. I've got more of this coming. Next time, we are going to look at how timers and interrupts work under the hood, because once you get that, you'll understand how microcontrollers multitask. See you then.